Hello students, welcome back to our channel HZSRA Maths and Tech. We'll be continuing with the real numbers chapter 1 exercise 1.2. So continuing with theorem 1.2, that is the fundamental theorem of arithmetic. Every composite number, I hope this is visible for you. So every composite number can be expressed. Let's make it a bit more visible for you. Every composite number that can be expressed, that is factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So what is saying that composite number, every composite number that can be expressed or factorized. What do we mean by expressed? That means that can be factorized as a product of primes. So this factorization is unique apart from the order in which the prime factor occurs. Okay, so order is not important. Factorization is important in terms that it should be product of primes. Okay, so coming to exercise on this particular theorem, fundamental theorem of arithmetic, we'll be doing this exercise. This exercise is based on fundamental theorem of arithmetic, theorem 1.2, given in NCERT chapter 1 real number. So continue with the exercise 1.2. We'll practice each problem one by one. So the first problem says, question number 1, express each number as a product of its prime, each number as a product of its prime factors. So the first one is 140. Let's say take 140. 140 we have to express as a product of its prime. Here it is given in this particular manner, but we'll do the desi way, the old method that we used to follow. Taking the number as 140, we'll take 2 as a divisor, 70, again 2 as a divisor, now it comes 35. Now it will be not be divided. We'll start with the smallest prime number as the divisor. If it is not divisible by 2, we'll take 3. If not divisible by 3, we'll take 5. So previously it was divisible by 2, 140, we got 70, and then it is divisible by 2, again 70, we get 35. Now it is not divisible by 3, so we'll proceed to 5. We'll take 5, it is divisible by 5, 5 7s are 35. So the whole product became 140 is equal to 2 into 2 into 5 into 7. That means this occurs 2 times. This is the product of 2 square into 5 into 7, which is the given answer. Okay, coming back to the second question. I hope this is very simple and easy. The second question says express 156. Again 156 as a product of its prime factors. 156 is a product of prime factors. Again we'll take in the similar fashion. 156 will do divide 156, I beg your pardon, we'll divide 156 by 2. We'll get 2 7s are 14, 116, 2 8s are 16. Again we'll divide by 2, we'll get 39. Again divisible by 2, no more divisible by 2. Then we'll take 3, yes, divisible by 3, 13 times 3 we get 39. So this 156 is the equal to the product of 2 into 2 into 3 into 13. We are getting the product of 2 times, hence this is 2 square into 3 into 30, which is the answer. Okay, proceed to the next. Third number given is 3825. So how do we know? See, here it is written like in this, sorry, here it is written in this particular fashion, but how do we know? So we'll start with the basic only. Is it divisible by 2? No, it's not an even number, so it is definitely not divisible by 2. Will it be divisible by 3? It might be. We'll have to add the digits of the number and then we'll find whether it is divisible by 3 or not. So 8 plus 3 is equal to 3 plus 8 plus 2 plus 5. That's how we check the divisibility of any particular given number, whether it is divisible by 3 or not. So 8 plus 3 is 11, 11 plus 2 13, 13 plus 5 18. That means 18 is divisible by 3. Definitely this is divisible by 3. Then we'll take 3 as a factor. 3 will be the factor, so we'll divide by 3. 3 1s are 3. Again it goes 3 2s are 6, 22, 3 7s are 21, 15, 3 5s are 15. Okay, now whether again it is divisible by 3 or not. 1 plus 2 plus 7 plus 5, we'll check. 2 plus 3 7, 7 plus 3 10, 10 plus 5 15. Okay, it is again divisible by 3, so we'll go again. 3 4s are 12, 3 2s are 6, 1 15, 3 5s are 15. Okay, again whether it is divisible by 3. 4 plus 2 6 plus 5 is equal to 11, not divisible by 3, so we'll take 5 as the next prime factor. So definitely it is divisible by 5 because the digit ends with 5 or 0. It will be divisible by 5. That is the basic thing that that students of 10th class must be knowing. So we'll proceed. 5 8s are 40, 25, 5 5s are 25. Again, it is divisible by 5. Again, we'll take 5. 5 1s are 5. 3 35, 5 7s are 35. This means 385 is a product of 3 into 3 into 5 into 5 into 17. So this is 3 square and 5 square. 3 square into 5 square into 17. That is the answer over here. That's how we'll be approaching the problem. Let's proceed to the next problem. That is, the next number given is 5005. Divide it with 5. Is it divisible by 2 or 3? No, definitely not. So it will be divisible by 5. We'll start with 5. 5 on the 5, 0 0 1. How about this one? Is it divisible by 5? No, definitely not. Is it divisible by 7? Let's check it. 7 1s are 7, 3 30, 7 4s are 28, 21, 7 3s are 21. Very good. Is it again divisible by 7? No. Is it divisible by 11? We'll not take 9 because 9 itself is a multiple of 3. So we'll take the next prime number, which is 11. Is it divisible by 11? Okay, 11 1s are 11. 3 33, 11 3s are 33. So this particular number 5005 is a product of 5 into 7 into 11 into 13, which is the answer. Now next question, express 7429 as a product of its prime factors. So 7429, we'll start 7429. Is it divisible by 3? Let's start. 7 plus 4 plus 2 plus 9 is equal to 7 plus 4 11 plus 2 13, 13 plus 9 22. It's not divisible by 3. So definitely it's not a multiple of 3, it's not a multiple of 5. 7, whether it's divisible by 7, 7 1s are 7, 0, 42, 7 6 are 42, 7 1s are 7, 2 remainders. So again, this is not divisible by 7 again. So we'll definitely jump to the nearest multiple as 17. Whether it is divisible by 17, definitely it is divisible by 17. So we'll take 17 4s are 68, we'll get 62 in hand, 17 3s are 51, we'll get 11 in hand, and 17 7s are 119. Okay, 437. Now we'll divide it by the next higher number, next higher prime number, 19. So this is divisible by 19. Let's check. 19 2s are 38, 5 carry forward 57, 19 3s are 57. So this particular number 7429 is the multiple of 17 into 19 into 23 of its prime factors. Okay, let's move on to the next question. So the next question says, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to the product of two numbers. First of all, we'll have to find the LCM and HCF pairs of integers. So definitely this particular formula is valid only when we are talking about two integers, pair of integers, when we are talking about pair of integers. So the first pair of integers is 26 and 91. Let's start with 26 and 91. The given prime factorization, that is 26 is equal to 2 into 13, 91 is equal to 7 into 13. So we get 13 as common. So 13 and 13 common. So HCF will be equal to 13, highest common factor. The common prime factor is 13. Now the LCM of the product, the LCM will be 26 is equal to 2 into 13 and 91 is equal to 7 into 13. We'll take 2, LCM is equal to 2, we'll take 7, and 13 is common in both the numbers, so we'll take 13 just once. So the LCM will be 182. Now verification, where LCM into HCF is equal to the product of the two numbers. What is the LCM? 182. And what is the HCF? 13. How much is 13 into 182? 2366. That's the number. Now how about 26 into 91? This also gives 2366. Hence verified. Okay, verified. Now next question, next pair of integers, 5 10 and 92. So 5 10, we'll have to express prime factorization of 5 10 again. If you're not comfortable like this, it's simply written over here. That's why it seems easy, but the numbers, the factors are not given. How you are going to find out? So we'll again start with the basic. We'll divide by 2, 2 2s are 4, 1 11, 2 5s are 10, again 10. We'll start with, is it divisible by 2? No. So divisible by 5, 3 or 5. So 3, 5 plus 2, 7, 7 plus 5, 12. 12 definitely divisible by 3. So 3, 3 8s are 24, 1 15, 3 5s are 15. Next, is it divisible by 3? No, definitely divisible by 5. So 5, 17 5s are 85. So the number is the product of 2 into 3 into 5 into 17. How about 92? We'll take 92 in the same fashion. We will find the factors of 92 in the same fashion. 92 will take 2, 92 divided by 2 it gives 46. Again 46 divided by 2, it gives 23. So the product of 92, the prime factor of 92 is 2 square into 23. So what is the highest, the common factor? Common factor is 2. There's only one time. Here 2 comes 2 times. That's why it's 2 square written over here. But here in 510, the integer 510, 2 comes only once. That's why the common factor is 2. There's any other common factor? Do you find any other common factor? No. So definitely 2 is only the common factor. Let's find the LCM. And how we are going to find the LCM? See, we'll write all the numbers here into all the numbers here minus the number already mentioned over here. So here 2 into 3 into 5 into 17, here into 2 is already taken. So do we have to write 2 times? No, you have to write 2 only once, that's into 23. So the factorization, the product will be 2 square into 3 into 5 into 17 into 23, and which comes to 23460, which is the LCM. So verification, 23460 into 2 is equal to 46290. Why? Because 2 is the HCF, 23460 is the LCM. Now product of the two numbers 510 into 92 is equal to 46920, hence verified. The answer is LCM is HCF is 2 and LCM is 23460. Now coming to the third pair of integers, okay, 336 and 54. Again we'll have to find out the LCM of 336. LCM or HCF? When we are going to find the HCF, it will be 336 like this. 54, how many times 54? 5, 6, 6 4s are 24. We can find with this particular method also. 6 4s are 24, 2 6 5s are 30, 32. How much do we get? 12 as remainder, 54. Again 12 4s are 48. How much remainder do we get? 6. 6 as remainder, 6 2s are 12. So 6 is the RHCF. Okay, here we can see if we express 336 is equal to 2 cube into 2 into 3 into 7, and 54 is equal to 2 into 3 into 3 square. So this is the common factor, hence HCF is 6. Now LCM, what, how to find the LCM? 54 and 336. Okay, let's start with 2. So how much do we get? 2 2s are 4, 14, 2 7s are 14. And how much do we get over here? 2 1s are 2, 13, 2 6 are 12, 16, 2 8s are 16. Again we divide by 2 or 3. Let's go for 3. 3 9s are 27, 3 5s are 15, 1 18, 3 6s are 18. So we have 9 and 56. Is there anything common? No, nothing seems common, but still we can go ahead. We divide this by 3, 3 3s are 9, and 56, 6 plus 5 11, not divisible by 3. Is it divisible by anything other than 3? 5? No. 7? Yes. 7 8s are 56. Again we break down. So we can write 8 as multiple of 2 to the power cube. So what is the LCM? The least common multiple is 2 into 3 square into 7 into again 3 into 2 cube. So it will be 2 to the power 4 into 3 cube into 7. So the LCM will be equal to 3024. Now multiplying LCM into HCF, we get 3024 into 6, which is 18,144. And what are the product? What is the result of the product of 336 and 54? That also comes down to 18,144. Hence verified. Okay. So here we understood how to find out the HCF and LCM of pair of integers, and how to verify whether the statement that the product of two integers is equal to the product of their LCM and HCF. Now let's come to the question number 3. There are total 7 questions in this exercise 1.2, and we'll do each and every question one by one, because finishing NCERT problems is the very basic thing to practice in mathematics, and that is very very important. And thereafter we can practice with other books also, but the basic thing is that you'll have to first solve all the problems given in NCERT book. Then only you can consider your chapter as complete. So the next question, let's proceed to the question number 3. So the question number 3 says, find the LCM and HCF of the following integers by applying prime factorization method, 12, 15 and 21. Now pair of integers are not given, there are 3 integers are given for each problem. So here we have to find the LCM and HCF of the integers by prime factorization method. So we have studied the prime factorization method. Okay, so let's start with the first question. Now how to approach the very first question? So it is given 12. So sorry, the ink is not good enough. We should say take the dark ink. 12 is equal to, how much is 12? 2 into 2 into 3, which is 2 square into 3. Next question, number 15. How much is 15? 3 into 5 is equal to 15. And next is 21, which is 3 into 7. So what should be the HCF? Do you find any common factor? That is 3. So we can say safely that HCF is equal to 3. And how much is LCM? LCM is product of all the integers given minus repetition of HCF. That is 2 square into 5 into 7 into 3, which is equal to 420. So LCM, your LCM is equal to, LCM is equal to 2 square into 5 into 7 into 3 is equal to 420. Now this is your answer. HCF and LCM. Similarly, proceeding to the next given integers 17, 23 and 29. Now here one thing has to be taken note of, that 17, 23 and 29, all these 3 given numbers are prime numbers. So they don't have any factors other than the number itself and 1. So their HCF will always be equal to 1, right? Because they have the factors. 17 can be factorized as 1 into 17. 23 can be factorized as 1 into 23. 29 can also be factorized as 1 into 29. So here the common factor is 1. Therefore HCF will be 1, but LCM will be multiplication of all the 3 numbers. Okay, which comes as 11,339. Okay, so this is the answer. So whenever prime numbers are given in such questions, you don't have to think too much. The only thing is that every prime number has 2 factors, the number itself and 1. So the highest common factor will always be 1, but their LCM will be multiplication of all the 3 numbers. Proceeding to the next number, which is 8, 9 and 25. So 8, they don't have. See, this question is also very important, because here 8 is definitely not a prime number. Again, 9 is not a prime number. 25 is also square of 5. So here also there is no common factors. The only common factor is 1. So their HCF will always be equal to 1. Although they are not prime numbers, but still, since they don't have any other common factor, though 1 will always be their HCF. And what will be the LCM? And again, the LCM will be product of all the factors of the given numbers. Sorry, LCM will be the multiplication of all the factors of the all 3 numbers, which comes down to 1800, which is our answer. Okay, let's proceed to question number 4. So what does the question number 4 says? The question number 4 says that given that HCF of 306 and 657 is equal to 9, find the LCM. Wow. Is it a very tough question? Definitely not. If you have understood the concept, the product of 2 integers, suppose the integers are x and y, the product of 2 integers x into y will be equal to product of the LCM of their LCM of x and y and HCF of x and y. So if we have known this theorem, we have understood the theorem, this particular question must be very easy for us. So how do we approach this problem? Since HCF is already given, that is HCF is equal to 9, we have to find the LCM. HCF is equal to 9, which is already given. So now product of the 2 numbers, LCM into HCF is equal to product of the 2 given numbers, 306 into 657. So here LCM, we have to find the LCM only, whereas HCF is given as 9 is equal to 306 into 657. So the LCM will be equal to 306 into 657 divided by 9. Okay, so the answer comes down to 22338. This is our answer. Understood? You will have to do the cancellation and division thing on your own. That much work you will have to do on your own. So let's proceed to the next question. Question number 5. Check whether 6 to the power n can end with digit 0 for any natural number n. Did you understand the question? If not, read it once again very slowly. Check whether 6 to the power n can end with digit 0 for any natural number n. Okay. So let's proceed for the solution. So powers of 6 can be 6 to the power n can be expressed as 6 to the power n is equal to 6, 6 squares 36, 6 cubes 6 to 216, 6 to the power 4 1296. So each time except n is equal to 0, whenever n is equal to 1, 2, 3, 4, we see here that the last digit remains 6. The number ends with 6 only. So a number ending in 0 must be divisible by 10, that is must have prime factors 2 and 5, which was the case 2 to the power n into 5 to the power n. We had studied in the concept of this particular chapter real numbers. So any number ending with 0 must be divisible by 10. That means it must have prime factors 2 and 5. Okay, but 6 to the power n has only factors 2 and 3, no factor 5. So 6 to the power n can never end in 0. So the answer is 6 to the power n can never end with digit 0. That's how we approach this kind of problems. Okay, next question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. What are composite numbers? We know there are two types of numbers, prime numbers and composite numbers. Prime numbers having only two factors, the number itself and 1, but composite numbers may have more than two factors. Okay, so let's find out. So the first number given is 7 into 3, 11 into 13 into 13 plus 13. We'll have to take 13 common over here, so we'll be left with 7 into 11 into 1 plus 1, which results into 13 into, how much will be the product of this 11 into 7? 77 plus 1, that means 13 into 78. Okay, here it is. So it has factors other than 1 and itself. Definitely it has factors at 13 and 78. 78 can also be expressed as 13 into 6. So this number will become 13 square into 6. Okay, so this is a composite number, the first one. What about the second one? Let's find out. The second one is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So here we can take 5 as common. So we'll be left with 7 into 6 into 4 into 3 into 2 into 1 plus 1. Okay, so what will be the product? 5 into 7 into 6 into 4 into 3 into 2. How much it will be? 3 into 2, 6. 6 into 4, 26 into 7. 7 into 24 into 26 into 6. That becomes 504 plus 1, which is equal to 5 into 505. Again, we'll take factorize this particular number. It will become 5 into 101. So here the product is 5 square into 101. It is definitely a composite number because it has factors other than more than two factors. It has factors other than the number itself and 1. It has 5 square as factor, 101 also as factor. That means this is also a composite number. Okay, so proceeding to the next question and the final question, the last question of this particular exercise 1.2. So find meeting time around a circular path. Meeting time, take note of this particular word, meeting time around a circular path. The path is circular. If Sonia takes 18 minutes and Ravi takes 12 minutes, so there are two candidates, two persons named Sonia and Ravi. One takes 18 minutes to complete that circular path, and suppose say this is the starting point as O. Sonia is taking it 18 minutes, whereas Ravi is taking 12 minutes. We'll have to find the meeting time. That means both of them started from this particular point. This is Ravi and this is Sonia. Okay, so how do we approach this problem? The simplest way is to take the LCM of 18 and 12 minutes. This is the standard method, and this is also one of the very basic method that I prefer. This is my way of learning and teaching. So we'll take 2 as the common factor, the divisor. So 2 9s are 18, 2 6 are 12. Again we'll take 3 as the divisor, 3 3s are 9, 3 2s are 6. Now the products are 2 into 3 into 3 into 2. So the products will be 6 into 6 is equal to 36. So after 36 minutes they meet again at the starting point. So this is the answer, and it was a very simple question. The only thing is required is that you know how to approach the problem, how to initiate the solution, how to approach the solution of the problem. Okay, so I hope this particular exercise should be clear to you. Thanking you. We'll meet in the next exercise, exercise 1.3. Thank you very much.